This mini lecture is entitled Multiverses versus the Anthropic Principle. You might recall that we've read about this anthropic principle from near the beginnings of the class. You may have some notes on Canvas that you can access for this mini lecture, whether on the screen or in a printed form. To review, the anthropic principle basically says that this universe has been fine-tuned or is fine-tuned such that human life is possible. And to build on that, the idea is that the constants, the basic nature of the forces, and so on, needed to be very close to what they are in order for there to be life and intelligent life, like we like to think we are. And all the other possible values, the theoretical values, a huge multitude, all these others would not work. So we had to have this so-called fine-tuning in order for our universe to exist. Now, most scientists and probably most scholars would say that science can't or doesn't dictate one's metaphysics, that one's beliefs about what the ultimate nature of reality is and whether there is some ultimate, divine, overall, larger reality is not a matter that science can decide. Of course, we've seen some exceptions with that in the conflict model, where some scientists say, well, science itself proves that the only reality is physical reality, and the only things about that physical reality that are true are the things that science can establish. But so that's an exception. But generally, no. Science can't tell us about the ultimate nature of reality. But the consensuses of science can limit or eliminate some possibilities, and they can provide some probability or at least provide some ammunition for theories that seem consonant with the scientific evidence. So, a lot of scientists, when this anthropic principle became well known in physics and beyond, said, well, this does seem to provide some evidence, some plausibility for the idea that there had to be some intelligent designer, or if not some purpose, at least some directionality in the universe. It didn't just happen by chance. And many physicists didn't like this. Certainly not all, but a fair number of physicists did not like the implications of that. You might recall that Einstein felt that ultimately we could come up with a theory of everything in physics that would explain why everything had to be exactly the way it is. Remember, God doesn't play chance with the universe, but not a personal God who's going to reward or punish us, but a kind of pantheistic divinity, right? That this intelligence is embedded in the universe, the superintelligence. Now, these folks who had problems with the anthropic principle didn't follow Einstein in having any kind of religious inclination, thinking of the natural universe as divine or sacred in some sense. Rather, they felt more that physics as purely naturalistic and nothing divine about it, kind of naturalistic in a more reductionist sense, could explain everything. And so the anthropic principle kind of said, well, maybe we need something beyond the laws of physics to explain everything. So various physicists started to come up with multiverse or multiverse theory or theories of multiverses. I guess you could kind of distinguish if we have, a universe means one world, right? So if we have many universes, if they're all totally isolated, totally separated from each other with absolutely no connection at all, we could talk about multiverses. If we just talk about multiverse, singular at the end, multi-world, there could be many universes that are all connected in some way or other. Okay. Now, before we get to these fairly recent multiverse theories or theories of multiverses, I do want to mention something that came earlier and provided the idea of more than one universe. And that was the idea of the oscillating universe. Once, even before the Big Bang became established, but certainly when it did, there was the possibility at that point, theoretical possibility, that our universe would expand to a certain point when it ran out of momentum and gravity would start pulling it back together into a big crunch, a super crunch, and then we'd have another Big Bang, and that universe could end up being totally different. So that would preserve the possibility that it was just chance that our particular universe in this cycle of universes, the cyclic view of universes, ended up the way it did, compatible with life and human life. All right, but looking at more multiverses that exist at the same time, or a multiverse that covers universes that exist at the same time. Well, in the most abstract sense, we could talk about a random generator of universes, although this tends to be more in terms of just games making use of multiverses at this point. But kind of the abstract idea that somewhere, somehow, there are universes being generated. Getting more specific, though, we can talk about multiple isolated domains that result from a Big Bang. So again, isolated meaning no connection, but just like our universe started with a Big Bang, it's possible that there could be a multitude of Big Bangs, and in this sense, these other universes are not connected spatially or by at least our space-time, right? But they may exist sort of now, but then every universe would be somewhat different in terms of its space-time configurations. But they all would start with a Big Bang. Another possible theory about how these universes get started. And the Big Bang, as you'll recall, is kind of a super dense something of energy, of matter, energy, whatever explodes. So this could happen in various places, unconnected. All right. Another theory is that of superinflationary bubbles. So we're going to kind of, in most cases, we're going to stay with this, inflationary thing, just like the Big Bang has this great inflation, this explosion or inflating at the beginning. The superinflationary bubbles say there are, in in the multiverse, or the whole of reality, there are these bubbles that become separate universes that inflate, that expand, and become separate universes. So there's this whole mass, and I'm not using it in the sense of our matter, but this whole mass of stuff, of energy and so on, that has these bubbles in this field, and they expand to form their individual universes. And some have raised the possibility that occasionally these bubbles, different universes, bubble universes that have inflated, could end up hitting each other, and that would kind of end up forming a combined universe, a combined bubble, kind of like when if you blow some bubbles, right, with the soap water. Sometimes a couple of bubbles might come together. All right, that's another one. Then there's also a quantum vacuum fluctuation theory of how multiverses may get started, or a multiverse might exist. And in this case, we could call it a multiverse because this tends to say that these quantum fluctuations in a vacuum happen in our universe, and can happen in other parts of our universe to start new universes that therefore have some connection to our universe. And I mean, we know within our universe there are quantum vacuum fluctuations that cause particle formation. We don't have any evidence that universes have another universe has come out of a quantum vacuum, but that's the theory that it could be. All right. Another version of this is, we're up to are we up to number 5 now, at least if we count a random generator as 1, the oscillating universe kind of 0, because that's kind of in our time sequence, but separate times. A 5th would be string theory and its understanding of multiple universes. And it plays on this idea that if you looked at Christian's PowerPoint on superstring theory, talked about how there are 11 dimensions, 10 spatial dimensions, 1 dimension of time. And the idea of string theory and the multiverse is that with all these dimensions, that new universes can spring from some of these dimensions. All right. Then a 6th, and this would be Lee, from great physicist Lee Smolin, who theorizes that each black hole actually conceals a new universe. So we've talked some about black holes, and that's things collapse into a super dense, extreme gravity that can suck anything in, that light or matter, anything that gets too close to it, it'll suck it in and reduce it to something very different than our usual dimensions of things. But Smolin believes that, or theorizes that, each black hole within our universe actually reveals or has started another universe that, of course, it's inaccessible to our universe, from our universe. you get sucked in, you'll no longer be whatever you were in our universe. You'll be in that other universe. And he does talk about the spin of black holes, that or rotation or spin of black holes, that he says there's some analogy to the rotation of our universe. So he believes that provides at least some possibility that this theory may, in fact, be true. Now, proving any of these is the rub, because basically scientific or the methodology or theories of science, what the scientific method involves or scientific methods involved is that you have to be able to prove or disprove a theory by some observation, by, mathematics may be involved, but you actually have to have some experience, some empiricism, right? We talked about that. Something empirical where we actually experience something that confirms that there might be a multiverse or multiverses. Superstring theory does talk about how, with all these different dimensions, that actually, and things maybe kind of wrapped around each other. You might remember if you watched some of the YouTubes on Christian's PowerPoint, there might be a wormhole to get from one universe to another within the string theory multiverse. Might be, but that to be able to build something to get to wherever that is, or might be, sounds very very maybe improbable. So all of that is extremely speculative, and some think they've come up with mathematical models that show what could be the case, but math by itself is just math, right? It doesn't not all math corresponds to anything in the real world. I mean, we can, certain math, right, that science has used in order to prove things, do experiments, and so on, ends up corresponding to physical realities, right? But the math involved with the multiverse or multiverses, at this point, we can't say it corresponds to anything in reality. So those are all kind of the one model of a multiverse that typically involves some kind of inflation, and whether it's all part comes from the same universe as ours, or the same mother of universes, we might say, as ours. So there's connections, or whether they're totally isolated. That's could be, depending on your theory, could be either way. But now finally we get to a totally different kind of beast, and that comes from Hugh Everett. His many worlds theory, as he calls it, or the branching universes or parallel universe theory, based on quantum theory. You might recall that there is uncertainty, there's probability, but there's uncertainty on the quantum level. So, an electron has a 15% chance to be at this energy level, maybe an 85% to be at this energy level. This particular atom in radioactive uranium, again as an example, has a such and such percentage chance to decay in the next 5 minutes. So it decays, or it goes in this energy level, and that's in our universe. But what about that universe where it might have been at a different energy level, given its uncertainty? In this universe where Schrodinger's cat might be dead rather than alive. Well, Everett says they all happen. All quantum possibilities get played out in different universes. So there's an endless or virtually endless number of universes being formed. They're endless because as long as we're going forward in time anyway, because there are many universes being formed from the quantum level all over the multiverses, right? And of course, if we want to kind of put this, if there's any, we could extend this if there's actual indeterminacy on the macro level, like with our decisions, we can imagine, another universe where instead of going to UNCP, maybe you chose to go to Fayetteville State or Eastern Carolina or whatever, parallel universes. So all kinds of possible ways to come up with some alternative to the anthropic principle, and that there's this one universe that at least is very conducive, very supportive of the possibility of life and indeed the reality of life, at least on our planet. And the science these days suggests that there's life and probably some intelligent life on millions, even billions of planets in our universe. The end.